one of the problems, if I could pull this up, turn this on. Oh yeah, 2 different brands of projector. I love that. How many of you guys are first-time college students? It's your first time. You're all like, I'm not going to tell you. Okay. So not only can you go for that grant here, free tuition for first-time college students, there's actually a continuation into the second semester if you meet GPA requirements and so forth. That's pretty nice. But also, somebody came out my office, and I just want to let you guys know, everybody on campus is here to get you in the right direction. So start with your teacher about specific things about the class, or just general, how the hell do I do this on campus? You can walk into any office and say, I just want to find out something about this, and they'll be like, you go here. I mean, you understand? So don't feel like you're wandering on campus by yourself. You're surrounded by people that want to help you, right? Okay. Let's see, I want to get to the book real quick. I wanted to do something real quick, but so I'm going to look at the problems in section 1.1, the 42 through 49, those problems. Some of you guys have tried it out. Some of you guys have yet to try it out. But those get a little bit freaky as far as what they want from you. So there's the free book, and oh, that's pretty cool. Damn. I like that. Yeah, this is what I get lucky with. Not red lights or anything. Just I scrolled to the correct part of the homework quickly. So let's see. Which ones did I assign? Let me double check. Oh, somebody's telling me. I like that. All right. So let's just try 42 out. The very first one. So they ask you in this section. Yes? On the PDF, it's 52. Is it the same in the book?
Yeah, it is.
Oh my God. It's almost the same. It's 51 in the hard copy. It's 52 in the PDF.
And it's 52 in this book.
Sweet. Oh, sweet. So depending on which version of things you're using, that's why I don't put pictures. Does everybody see what we're working on? You guys okay with that? Okay. So this is the one I signed, 45, whatever the hell. We're going to do 42 as an example, just to show you how this is supposed to work. So it says, for each of the following, identify the population, the sample, the parameter, the statistic, the variable, and the data. So population and sample, let me go this way since that's where my camera is going. Population sample, we know those pretty well. Parameter and statistic, what is that again? What's parameter again? Parameter? Well, population is all the people, so be careful. Parameter is that's the population. What's the parameter? So the population is
of all people.
Oh, good. All right. So it's a description, a numerical description. So if your population is all gross fund students, the parameter would be 22% of all gross fund students, like jazz.
So it's a description of.
It's a description of. It's a numerical description. Like you analyze the population and you find a result. So the percentage of the population that does this, or the number, the average height of all gross fund students is something, that would be a parameter because it's describing all gross fund students. Parameter, population, right? As I spit on the splash zone. The statistic is the same damn thing, but it talks about the sample. All right, it's the same thing. So if I say the average height of a gross 1 student is 5'6", that's a parameter. I'm talking about all gross 1 students. If I say the average height of the 87 gross 1 students I looked at was 5'3", that's a statistic. Just because I'm talking about the sample. Don't make more of that than it is. That's all it is. You gotta love the fact that the letters match. Is that all right?
Yeah.
Okay.
It is now.
So parameter is when you analyze the population and you say something about what you found. Take the average height, take the percentage of people that drink coffee, whatever. So normally a parameter in a statistic is going to be a percentage or an average. Could be other things, but those are the two biggies. I like it. So probably when you answer these parts, you're going to use the words the mean, or the average, or percentage. So in statistics, what's really weird about the word average? When I say average, what do you guys think of? How do you find the average of a set of numbers? Add them all up. Divide by mean. I like it. That's what is known as the mean, specifically. The word average actually means a couple different things. So we didn't just call it a mean because it's a 4-letter word, starts with M, and we're math people, but the mean is the official word for what we think of as the average. So when you see the word mean, they mean what we think of as average. Are you guys with me? So if I said the average height of the students in this classroom is 5'6", I could also say the mean height of the students in this classroom is 5'6". They mean the same thing. I love it. Sweet. So far so good. Some of you guys are waking up at the moment. Okay.
So these were making up the numbers?
No. You don't have to. So if I said the average height of all gross 1 students, is that a parameter or a statistic? It's a parameter. There you go. You don't have to give a number. You just have to state what it would be. If I said the percentage of the 87 students I talked to enjoy the film Cabaret,
That's a statistic.
that would be a statistic. All right. Okay. All right. So I'll go through an example. Because it seems like they don't give you enough information. So a fitness center is interested in the mean amount of time a client exercises in the center each week. What's the population?
All clients.
Do you guys see that? They're not going to tell you that. You're going to have to figure it out. So if a fitness center is interested in the mean amount of time a client exercises in the center each week, be a little more specific. The population is all clients of the fitness center. Not all clients, period, because then it's like all clients everywhere. Why would they talk to other people? They just want to know about their own center. All right. I want you to understand what's happening right now. I'm showing you how to do some of the homework problems. So, should be a lot of writing. Should be a very interesting moment. Right? Okay. Is everybody cool with that first piece? So every single one of these, they're not going to just say the population, is it? You're just going to have to take a second to figure out what is their population. If I was interested in the average potato consumption of a person in Wyoming, what would my population be? All people in Wyoming. Not all people in the U.S. How's that going to tell me about Wyoming, right? Okay. How are we doing so far? So this does take a little critical thinking. They aren't going to just say, here's the answer, copy this shit down. No. The sample. Now here's where you could be a little creative. Or not. So what is a sample? What's like the definition of a sample?
You could fairly or openly be able to pick them.
No, not random sample. That's a type of sample. But a sample is a...
Be small.
Beautiful. It's a subgroup of the population. I like it. So you actually could say, right here, if you wanted to, for part B, you could say the sample is a subgroup of all the fitness center clients. That's more like a definition approach, and that would be acceptable. Or, sorry? The sample is a subgroup of all the fitness center clients. No, what did I just do? What's the definition of a sample? A subgroup of the population. What did I just do? Replace the population with what the shift is, right? That's all I did.
So that would be the answer.
That could be an answer. You could be more creative and say 100 randomly selected clients. I love it. That's that's fantastic. We're like, screw creativity. Just tell me what's right now. All right. So I'll take either one. You could kind of, because it says give examples where appropriate. So that could be an appropriate place to put an example. 100 people of the 100 clients. Don't say 2 clients. I'll get you worried. Is everybody good so far? Let me know if you're not. Like I told somebody this morning, if you have a question, at least 8 other people have the same question. Don't feel like you're the only one. Right? Yes?
Is sample the only one that you can give?
No, data is another one, for sure. Because data would be the answer to the question. We'll get there. Yes? Okay, good. Come back. Doesn't help with all that. There's a car alarm. Everybody run, see what's happening. Why do people have car alarms? All right. Population, all the clients of the fitness center. Sample, a subgroup of all that, the clients of the fitness center. You can be more specific, say 100 randomly selected clients. Either way, how are we doing?
Good.
Okay. You gotta appreciate a teacher showing you how to do a problem. Okay.
Yes.
All right. The parameter has to describe what? The population. In our case, what was, and then you just reference, you go back. What did I write? Oh, all the clients of the fitness center. So what's the parameter going to be?
The client.
The mean amount of time that all clients spend in the center. You guys with me? It's a numerical description, mean amount of time. A numerical description of the population. So mean amount of time that all clients spend in the center. Do you see how beautifully that D just comes off of that? D would be the mean amount of time that, what does statistic represent? Statistic represents a sample. So if you said the sample was a subgroup of all clients, the statistic would be the mean amount of time the subgroup of clients spends in the center each week. Do you see how that's a numerical description of the sample? Or if you said 100 randomly selected clients, then D would be the mean amount of time that the 100 randomly selected clients spend in the center each week. You just reference the sample. So you go back to your answer to part B and make sure that shows up in your answer. Because the statistic describes the sample. It's probably good.
Good.
Yeah, like it. Like so. Everybody's looking, so that's a good sign. Okay. Who remembers what I said the variable was related to? I'm walking around. I'm the person. I am the head of the fitness center. I'm going to walk around and talk to people. What am I going to ask people? How long you spend? More likely, I'm not going to ask them because the dude that comes in there for like 30 minutes a week, I mean, it's supposed to be like 8 hours. So you probably don't see me. So I'm probably going to go into the records in the computer. Yeah, exactly. And see how long people are there. Right? But what is the question I'm trying to get answered? How long does a person spend in the center every week? Right? That's the variable. The length of time a client spends in the center. I really want to make sure you understand. The variable is related to the question you would ask. So just think to yourself, whatever the situation, what would I actually ask or look at or want answered? That's the variable. What's the idea of a variable? It has many different values, right? Because what kind of answers could I get? A lot of different numbers. That's why the variable is the length of time. What's the data going to be? Here's where you just give examples. What could you find out? What could somebody's record say? They were in the center for
45 minutes.
45 minutes in a week. Ooh, let's put in the time in. 0 minutes in a week because they just got they could just say, yeah, I belong to a gym. Yeah, this is pure, this is beef cake. Yeah. Right? Or they could spend 20 hours in the gym. 10 of it talking, 10 of it working out. They go to the gym, so it's really funny. And 5 of it go, ugh! Right. Sorry, that's you. Sorry. You guys feel a little bit better about these problems? And of course, if you haven't tried these out, you might feel worse because you didn't even know these were there. But if you write those down, that's basically how every single one of these works. Yes?
So when you're answering that question about the data, how, what are
Oh,
you
sorry.
looking
So
for?
you would just say 45 minutes, 8 hours.
Just throw
That's
it.
where you
how-
definitely want to give examples. Because the data is a list of all the answers. That's what the data is.
Right.
The variable is the question you ask, and the data is all the things you're writing down, all the answers.
Throw out some numbers and some.
Yeah, totally. So that's exactly where they meant give examples were appropriate. They were specifically talking
So
about
just make
the
up.
data. Make up shit. I like it. But make up shit that makes sense. Right? Don't say 3 years. I'm like, and cram 3 years of work out in a week. That's what some people seem to be trying to do. Is that better? Okay, all right.
So each different scenario is just.
Each different scenario is just giving, some of them instead of mean, they say, does everybody know what the word proportion means? What is the word proportion? It's not a dolphin that does math. It's not a proportion.
Yeah, they're
Like a division.
It's a percentage. It's another name for percentage. So when you see the word proportion, you can use the word percentage if you want to. It means the same thing. So like up here, the parameter was the mean amount of time that all the clients spend. Down there is going to be the proportion of all voters in the district that think he's doing a good job, for example. Right? That would be the parameter here. Don't just use the word mean everywhere. It's great. Just stop and think about what you're doing. All right. So again, you can try those out. You can come with specific questions about some of them. Anybody try any of those out? Think that there's a different, any questions on the other ones now? That we've gone over one example?
I just think I did.
Can you explain statistic again?
Which one?
The statistic?
I really, if the parameter makes complete sense, wherever in the parameter when you say all, the statistic you replace it with subgroup of or like 87 randomly selected. The parameter and the statistic will sound exactly the same because they both tell you the same information, just about different groups. Maybe. Some of your eyes I could see like, oh shit. Isn't that horrible? It really isn't. It's just words, you got to get used to what they mean and how to use them. That's all. I never give you like a definition quiz or something. I never ask you define parameter. But you have to be able to use it correctly.
So you're saying if you have one, you can't have the other percentage?
Yeah,
Because
if you have a parameter, it can't also be a statistic and vice versa. Because the parameter must talk about the population. The statistic must talk about the sample. Is that what you're asking? Yeah.
And
Yes.
the variable is exactly what we're looking for. Like,
Yes, what you want answered. It's related to the question you would ask. So if I wanted to know what percentage of people have blonde hair, what am I asking people? What am I looking at? I'm asking, what color hair do you have? The variable would be the color of a person's hair. The data would be brown, bald, whatever, right?
So what would the answer be for the statistics according to if the parameter is the mean amount of time?
Yeah, the parameter is the mean amount of time all clients spend in the center. The statistic would be the mean amount of time the subgroup that you looked at of the clients are in the center each week. Yeah.
Would you want to write like the subgroup, or would you want to make up the
Like I said,
statistic or?
totally up to you. I'll take either way. So, yes.
The idea is only we have to give examples.
Yeah, the data is the only one that you really have to give examples on because data is answers. So it's hard to describe the answers. It's easier just to give possible answers. Yeah. Okay. All right. Anything else from homework? I knew I wanted to go cover that. Anything else that was freaky in homework stuff?
1.2, I think for number 16, I just didn't get how to put the table. Like the tables.
Oh, we haven't talked about those yet. We haven't done frequency tables. This is from section.
It's 1.2.
Yeah, they actually.
It's 1.2 homework. Number
But it's
16.
actually from section 1.3. It's another little thing that they have incorrectly put.
Like sigma.
That's right. So we haven't talked about this stuff yet. Relative frequency, cumulative.
So I shouldn't know how to put those tables together?
You shouldn't necessarily be able to. You can look at some examples and piece it together. Okay.
that, how that one works?
We're going to talk about those today, so you should be able to do those after today. Yeah. Okay. So we have a few definitions left to talk about. We're going to talk about how to set those tables up. We are going to take the little field trip later today. I'm going to try to get us out of here early because I have a 9 o'clock meeting that I haven't finished getting ready for. Yay, Jeff. Right? So sometimes when the teacher lets you out early, it's not just them being really nice. It's them being nice to themselves. So,
Huh? I said, if you ever don't want to prepare for meetings and you
Oh, you're so nice. Okay, let me see. Blah, blah, blah. Trying to reset this room again. Come here, camera. I wish nobody else had this room. That'd be awesome. Just put it the way I want it. Okay. By the way, remember, this isn't just video for me. This is up. There's a link to the YouTube thing on the website, so you can kind of rewatch lectures that were like really awesome, or if you just need to remember what the hell I meant or what I said. Okay. So let's do this. There's just really a couple of definitions. Is that discrete and continuous thing? Protected. Yes. What's that?
So that'd be a funny video.
Oh.
Have
This is off at his commandment. All right. So I can't remember what section this is in, but discrete versus continuous. This is types of data. So think about that. Let's start with the word continuous. This should be the one that might be a little more familiar. What do you think when I say the word continuous? Not that it never ends, to be honest. Like, is this a continuous, which one of these is a continuous line or a curve? The bottom one is continuous. It doesn't skip values. It doesn't skip. It takes on every value in the middle, right? So, a counterexample, something's not continuous data would be the number of doors on your car. Can the number of doors on your car be anything between 0 and whatever? Meaning, can you have 2.54396 doors on your car? Can you? What? Right? No. Our number of kids in your house. I hope to God you can't have 3.7 kids. I'm like, I'm not coming to your house. There's my 3. There's the 0.7. Okay, what is happening? All right, it's either a kid or an 8. It's either a door or an 8, right? How many TVs? You don't go, well, we have 2.5 because that one works half the time. No, it's a TV or an 8. You can add adjectives. It's a broken TV, but it's a TV, right? You guys with me so far? So that's discrete data. Discrete data are the ones that skip values, that don't take on every possible value. Like a big key phrase, not that's used always, but it's used a lot of the time, is number. Get out of there. Number of. Another thing that they like to use is the idea that it's countable. I can count the number of kids in my house, right? There is a certain maximum you would get to where you can't stuff any more kids in the house. One more. Right, so it's countable. Can you count the weights, the possible weights of a backpack? No. So if I ask you, how much does your backpack weigh? You'd say about 5 pounds. But what could you say? 4.92673 net in pounds. Depends on how precise your scale is. You guys starting to understand? That's continuous. If I say, if somebody says the weight of my backpack is 5 pounds, is that discrete or continuous data? You don't say discrete just because the damn thing is 5. You say continuous because what could it be? 4.98. If I say my car has 4 doors, that's discrete because it can't be 3.876 doors. You guys see the idea? It's what possible values can the data take on? Anything between two things, continuous. Only whole numbers or something, discrete. So what about price of gas as listed at a gas station? So the price of gas could be listed at a gas station as 3.572664976422222223. It can be? Have you seen that? Do they have a long enough freaking board for that shit? No. What is it always? Always, always. 3.569. You guys ever notice that? They have a third decimal place, so it's actually 357. You assholes. Right. Have you guys noticed that? Some of you guys have. Some of you guys are like, I don't look anymore because those numbers are too high to worry about. I understand. Some of you guys are like, I take the damn trolley. So gas prices are discrete. As they're listed, they are discrete. They can only go up to the third decimal place. Do they include every possible value between 0 and something? No. No. You're not going to see 3.2894663. I kind of want to go to the gas station. This long-ass board that wraps around the place. Okay, can you be more precise? Continuous would be most of the things that we measure. Height is continuous, thankfully. You don't grow in like half-inch increments. Boop! Right? When you're little, it might seem that way sometimes. You wake up the next morning, holy shit, man, what happened? But we grow continuously until a certain age, thankfully. We're not all 50-foot behind us. So continuous would be most measurements, like physical measurement, height, weight, like the weight of the backpack example, length. You guys with me? So if I said number of words I could type in a minute. Number of words I could type in a minute. Discrete. Right? You're not going to say if that's a word or it ain't. You know, it's 0.2 of a word. I was going to write this. No, it's not a word. Stop. Right? You guys understand? Especially what was the key phrase in that, what I just said? Number of. It's countable. That's discrete. Right? If I said, I live 20 miles away from college, is that data discrete or continuous? Continuous. Oh, it's so evil. I know I said 20, but what could it have been? 19.987. Right? If somebody says to me, you know, how far away do you live? And they say, I live 11.3467. All right, Spock, what the shit? Right? You live 11 miles or 12 miles. As a human, we're going to round it. This is all about what could it be. Right? I will not trick you, but I will give you questions like, what type of data does this represent? The backpack weighed 8 pounds. People are going to say, discrete, it's a whole number. No, it's continuous, because what could it be? Yes?
So why is something like height continuous if it actually does stop at a certain point?
Oh, I see what you mean. So continuous doesn't mean infinite. Right? So like the weight of a backpack cannot go to infinite weight, because at some point, it's going to fall apart and not be a freaking backpack. It's going to be a bunch of material that used to hold it, right? Because, as you see, so there should definitely be a stopping point, and it's still continuous.
Just everything in between 0 and
0 and something. I like it. You guys
But
with
you
me?
said the price of the gas.
As listed. The price of gas as listed. So, yeah. Oh, it's so evil, Jeff. What the hell's your problem, man? So, I'm gonna try desperately not to be tricky. And if I feel like a question can be interpreted a few different ways, I'm gonna base the points on how you explain your answer. I think I already told you there's a few situations where I'll take a couple answers based on how you explain yourself. So I'm going to say what type of data is, remember nominal, ordinal, interval ratio? I'm going to say what type of data is this, what type of variable? And you're going to say ordinal because there's an order to it. When you come in, you get this. When the answer could have been nominal or interval, but I'm going to do it based on how you explain yourself. Do you understand the idea behind the word? Okay. So my intention is not to be tricky. My intention is to make sure you understand the idea. Okay. Maybe. By the way, I'm going to have quiz 1 on chapter 1 net. Good job, Jeff. Next Wednesday. We're going to finish chapter 1 today, so homework should be done by next Wednesday. I base my quizzes on that fact. Yes? Oh, not necessarily. It could be. We'll see how it comes out. So far, no. I used to do this week of quizzes, the walk. Week of quizzes. So we'll see that. It just depends on how things fall. But to be really honest, we probably will end up having another quiz the following Monday, but we'll talk about that next week. Anything about discrete continuous, you guys? Don't look at the number I give you. Think about what the values could be. Now, here's a really evil. The average number of people in the room was 11.3. Is that data continuous or discrete? Number of people. Now, what freaks, is everybody cool with the fact that the average can be anything? When they say there's the family has an average of 2.5 kids, they're not saying there's 0.5 of a kid running around, right? Some like just legs. Really quiet. But it freaks everybody out. Doesn't eat much. All right, sorry. The average can be anything because the average involves dividing by the number of. So you wouldn't want to round 2.5 to 3. If I said there's 10 couples and they have an average of 2.5 kids, can anyone tell me how many total kids are involved? 10 couples and they have an average of 2.5 kids. How many total kids? So there's 10 couples I talked to. The average of 2.5 kids. 25 kids. Because how do you find the average? You take the total number of kids divided by the number, 10. So what divided by 10 is 2.5? 25. So if you round this to 3, then you're telling me there were 30 kids and you're lying to my face. That's why averages can be decimals, because that's the only way to be honest. When you divide, anything can freaking happen. We know this shit, right? So never round your means too much. I'll try to be explicit on the tests and quizzes where I want you to round it to. If you round it too much, you're being really dishonest. Okay. I like it. How are we doing so far, you guys? Yes?
So even though that's countable.
Oh, okay. No, I didn't say anything about what type of data. This would be what kind of data? Discrete. Because what am I asking everybody? How many kids? And what are they telling me? Only whole numbers. If they tell me something other than their whole number, I'm going to further investigate.
But your first example was that you can't use 2-point-something children as a discrete example.
That's the average. So data can be whole numbers, and when they average them together, that can come out to anything. So like I said, do not look at the number I give you. This is discrete, even though the number I gave you is a decimal number. And then 8-pound backpack is a continuous data because it could have been anything. Don't just say 8's whole number is discrete. No, that's not the idea. It's what it could be. Okay. All right, that's enough of that. I don't want to make too big of a thing out of that. It's too late yet. All right, so let's, I will tell you this explicitly. Sometimes I don't even say this, just to see who asks questions. I'm not going to talk about 1-4 at all. So I want you to try to do that homework. You're going to have to read section 1-4. Shit, Jeff. And come with questions. Section 1-4 has some definitions. They are about how to put experiments together. So if you're going to test a drug, you guys know how to set up kind of experiment. Don't tell me you've done it. Yeah, I had some friends that took the shit. And, How would I set up an experiment for a drug trial? You guys know. What is it that they give you that's not really the real drug? Placebo. Normally it's a sugar pill. And then there's the thing about, well, if the placebo has a better effect, you just give everybody sugar pills and then, who knows? So what would you do? Like I could take all these people here and I could give them, what? The real drug. I love it. And then these people here I can give placebo. Now these people left out, what would these people get? Nothing. They would be the control group. They're control group because I'm like, perceived naturally. And then I'm going to see, are these people different from those people? That would be the placebo effect. And then I'm going to see, are these people different from those two? That would be the effect of the drug. Now you can get a lot more into it. You can control variables. So I want to make sure that these guys are really representative. Or I want to make sure that I only have men in my sample because I want to see maybe men and women have different reactions to drugs. Or I only have people that are this old. I only have people that don't have a heart condition. I can control for okay. That's section 1.4. You're going to want to read that section and then do the homework. It's like a natural way to do it. Sometimes I'll do that and I won't even tell you. And it all depends on if somebody comes and asks the question. I'm not trying to be evil. I'm just trying to make sure that you know that I'm only one piece of this class. Another piece is the book. Right? And another piece is whatever the shit you find out there to help you. Right? Videos, Khan Academy. You guys ever heard of Khan Academy? You can just go to YouTube and type in, types of variables and then just see what videos pop up. Find somebody you like and watch them. I love it. Like, I don't understand this Jeff dude. What the shit? Let me find something that makes sense. Huh? You'll find my video like, I'm in a loop. I can't escape this guy. All right. So let's talk. If there's no other questions specifically from chapter 1 stuff, I want to finish this up. This is section 1.3. I don't know why I put it 1.2. So let me do a type of problem here. Anybody in here that doesn't want to tell me how old they are? Anybody? Because I'm 45. There you go, right? It's really weird when you get older. You're like, I don't feel different, but holy shit, it's been a while since I was born. Anybody in here under 18? Okay, how old are you? 17. Anybody else under 18? Anybody else? No. Okay. So I got one 17-year-old. She's there. And then anybody 18? Oh shit, let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. 18 normally is the one that happens the most. 19? 1, 2, 3, 4, 5. You 19? Yeah. 6, 7, 8, 9, 10. All my 19-year-olds went over there almost. I forgot what the hell I just said. What did I say? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I think it's what I said. Any 20-year-olds? 1, 2, 3, 4, 5. See, 21? 1, 2, 3. You can go sell like you know. 22. Legally. 1, 2. Okay. 23. 1, 2, 3. Oh, this is exciting. 24. Sorry, 24. 1. 25. All right, anybody who's over 25? All right, stop. Let me see. How old are you?
30.
Say again?
30.
30, okay. Let me just put over here. 30. Who else?
34.
34. Loud and proud. Do it. Yes.
43.
43.
30.
30. 26. Your insurance went down last year. 38. 37.
31.
31. Okay. All right, let me do this then. Let me see. Put 24 over here.
And 33.
33? Sorry, I skipped somebody. So you're just going to put an over 24 category down here. So I mean, 1, 2, 3, 4, 5, 6, 7, 9, 10. Over 23, I guess you should say. Good Lord, Jeff, you and your memory. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. This column we just created is called the frequency column because it's how frequently this data point showed up. Now we will discuss later how to develop these. These are called classes. The frequency here would just be how frequently a data point showed up between those two. You do that if you don't have a lot of repeats in your data. Here, we have a lot of repeats in our data, right? But you make classes if you don't have that many repeats. So you can group things together so you get a feel for the distribution of ages or the distribution of whatever. How are we doing so far? Semi-decent. All right, so this is called the frequency. You'll see it right up there in their table. What the hell would relative frequency is? Something I affectionately call the real freak. What would the relative frequency be? Relative to what? Why is this not very explanatory? There's 5 20-year-olds. Is that a lot or not a lot? Well, what would you compare it to? How many total people? If there's 1 million people and 5 of them like lima beans, then that's not very many. That's a very small percentage. If there's 10 people and 5 of them like lima beans, like, holy shit, half the people. So this really is another name for percentage. Relative frequency. It's this frequency relative to the total, divided by the total. And what total number of people do I have up here? 15, 20, 33, 48, I think. I should probably put myself in here. Let's have 49. Make that 11 down there. You guys cool with that?
Yep.
Hey, whatever, man. Change the numbers. I like that it's 49, sort of, because we get some neat old decimals. We got to round up a little bit. So what percentage of people are 17? 1 out of 49. And what is that?
0.
Yeah, 0 point something. 0.2, blah, 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 something. Anybody have a calculator? Oh, sorry. 0.0204? Okay. So we'll say 2.04%. By the way, and of course it keeps going, whatever, but we'll say we'll round it to 4 places. A lot of times you're going to end up rounding decimals to 4 places, just to make sure we have enough detail. Is everybody cool with changing decimals to percent? That's kind of an evil question, like, I'm not. Me. No. What I always show people is decimal percent. Alphabetical order, right? So if you want to go decimal to percent, you move the decimal that way. Why twice? Because the percentage is out of 100. There you go. Right? Okay, just want to make sure, because I always have people, percentages are less and less understood. What's the word of mean? If I say like 12% of 80, what would you actually do? See, that's there. Of. Everybody came out of high school knew of meant multiply. That's just the direction. Now, they're like, well, that's not important. We don't want them knowing that shit. We can't sneak shit by them if they know that shit, Jeff. 15% off. That's 2 cents off. That sounds great. No, check the damn thing yourself. All right, I'll stop. So of means multiply. 12% of 80. 0.12 times 80. 1/7 of 38. 1/7 times 38. Of means multiply. Used to be known all the time. Now it's barely known. All right. So how do I get 14 out of what? 49. So it's going to be 0.28. Okay. 2857? So 28.57%. Is it 7 or is that cool?
28.5714. Yeah.
Okay, cool. All right. So truly round. Don't just cut. Everybody cool so far? So what does this mean right now? What does that mean? There you go. About 28.5% roughly of the class is 18. Which is expected, because normally the class is going to be made up of a lot of people that are straight out of high school. But of course, community college, you do get a lot more variation, which I like. And then 10 out of 49, wherever the hell that is.
20.04, 20.08, so 20.41%.
Well, like, yes, 0.204008. So 0.2041, 20.41%. And then so forth. 5 out of 49 will be 10 point. Yeah, it'll be 10.205. 10.21 or 10.2?
10.
Oh, okay, cool. And then 3 out of 49, 2 out of 49. There's a repeat, that's nice. 11 out of 40. So, is everybody cool with that? What should all these equal add up to be at the end? 100% or close. We rounded, didn't we? So if it's off a little bit, you're fine. If you get 95%, oh shit, you left something out. If you get 103%, no. But if you get 100.2%, yeah, you round it. Or 99.7%, you round it. Not a big deal. But it better be close to 100 freaking percent, or else something went wrong. I always get somebody that turns these around, and then not really gets freaking. Okay. Is that cool? All right. And then, let's just real quick. What is 3 divided by 40? Anybody do that? 6.12.
12, yeah.
2, so that's 6.12. Yay. 2 49ths. 4.08.
8, yeah.
Ah. 4.0. Is that cool? And then 11 divided by 49. That's going to be 22.45. That's my one skill, so I got to show off every now and then. All right. So frequency is just counting how often things here show up. Ew. Relative frequency is just making this into a percentage, so it actually means more to us. Not hard. This last one, cumulative frequency, let me start this off and see if you guys catch on. So far I've got 2.04%. Now I've got 30.61%. Now so you accumulate as you go. So at this point I've got 2%. At this point, 2 plus this, bam. And now this picks this up. So what does cumulative mean? Accumulate, right? So what should I get at the bottom? Close to 100%. So 30 plus 20, so it'll be 51.02. And then 61.22. And then 67.34, I think. I don't know. 71.42. That could be off. Hopefully not. 5, 6. And then 99 point, yeah, so then I get 100%. Yay. Sorry. Is that evil? No. It's like, please make more problems like that. I would hope. Yes, enjoy it while it's like this, yes.
So what does the cumulative frequency provide?
I can actually graph these. I don't actually do that. I don't worry about it. But it kind of shows you where the jumps, where you pick up the most. To be honest, I don't worry too much about that graph because you can tell here. I'm going to pick up a lot here because there's a lot there, right? So I do make you get this column put together because it's going to be everywhere in the book. But there's a graph I can make that I don't make you guys make based on this. I want you to understand what cumulative frequency is. All right, cool. Let's see. Yeah, we got plenty of time. So let's do this. Let's try a different type of this problem out. So bring out what they want from this. I know, it's so beautiful. By the way, you guys in the front row, if that decides to take a break, let me know. It takes union breaks. Okay. So let's try a slightly different problem. By the way, I'm going to remind you guys again about the survey. We've got about almost half of you guys have filled the survey out. I'm going to make a lot of problems based off of your answers. So like on the quizzes and tests, there will be, this is your class. Answer these questions about this data. So you can kind of see, compare yourself to the overall makeup of the class. So on Monday, I'm going to have a worksheet that gets us from this into Chapter 2. Chapter 2 is where we start to make graphs based off of this. They're called histograms. And kind of, here's a bar graph. You guys have seen this before, right? And then here's a histogram. Do you see how it has no gaps? Because this is truly numerical. So it's got to be continuous kind of data, right? It's going to be, and this would be like BMWs and Hyundais or something. There's no scale to it, right? This is for qualitative data. Histograms are for quantitative data. So that's where we're going to start creating ourselves. Let's focus a little more on this kind of table thing here. So let's say I have a table that looks like this. In fact, I'm going to do a little bit better than that. Yeah, sure, probably. And this is like ages of people at a bus stop or something. Let's say ages of people, just to give it something. So here's the data. These are the classes. Let me ask you this real quick. If I ask you a certain way, you're going to give me the wrong answer for sure. So let me ask you this way. How far apart are the beginnings of each class from each other? 5. That's the class width. That's how wide the classes are. If I just said how wide is each class, you would have said 4, wouldn't you? It's not quite right. They're actually 5 wide. How many numbers? 10, 11, 12, 13, 14. Oh, shit. All right. So here's the data I'm going to use. I'm going to put them in order. Next week I'm going to